Welcome to Sketching Quadratics with Critical Points. Let's start with an example of what graphing this would look like. Y equals negative 2x squared minus 6x minus 3. Take this in steps. There'll be 5 steps we take. First one is the y-intercept. Of course, y-intercept is when x equals 0. So we plug in where x equals 0. So we're looking for the value of the function y when x equals 0 is equal to that function, negative 2. And instead of x, we put in 0 squared minus 6 times 0 minus 3, and that equals minus 3. So the y-intercept is at minus 3. Second step we take is the axis of symmetry. Determine where it is the parabola repeats itself. From where to where. So on there, we have the formula x is equal to negative b over 2a. B is negative 6, so we put that in here, negative 6. Then we have 2 times a. 2 times a is the coefficient of x squared is negative 2, so it would be 6 over negative 4 is equal to, reduced is negative 3 over 2. Next piece is the vertex. Vertex is that very farthest point, either the highest or the lowest point. And to find that, we take the axis of symmetry, that value, the x value, and put that in for the value of x in the function. And we determine that y value on how high up it does go for that value. So it would be negative 2, that same function, times the x squared, and that x in this case is negative 3 over 2, and then subtract 6 times that negative 3 over 2 minus 3, and that would equal 1.5. So we have the vertex at that point. The point is negative 1.5, comma 1.5. And then last step, one more step after this, but pick a point. So we're looking at picking a point, and let's first graph these. So before we do this, let's look at what we've got so far. We've got the vertex at negative 1.5, 1.5, so we graph that point. We have the y-intercept at at 0, comma negative 3. We have the axis of symmetry at x equals negative 1.5. And we have now, we're picking a point somewhere between here. So we saw this and said, well, let's pick the point between here. So that's how we pick this point. Y equals x, y value for x equals negative 1 right in here. To put a point in there, and we just picked it. So then we put it in so we can find the ordered pair for this location. And that would be negative 2, same function. Negative 1 is the x value squared, minus 6, minus 1 times minus 1, minus 3, that works out to be 1. So our point is negative 1, comma 1, and that's a point on the curve. But look at this. If this is the axis of symmetry, we can find one more valuable point. What happens? We're going to take it one step further. By the axis of symmetry, what do we find out? There's a mirrored point. A mirrored point off this one comes across the axes, the same y value, same distance from the axes across on the other side. That value, that point would be negative 2, comma 1. And we can do the same thing in reflecting this one across the axis of symmetry to find this point. So based on what we have here, let's do this example. Do the example in green. You can pause the video and graph that. Graphing this one would look like y-intercept at 3, axis of symmetry at 2, vertex would be 2, comma 1, And then we would pick a point somewhere that would help us understand what the graph would look like. And in this case, we have the axis of symmetry, and we had the y-intercept, so we picked this point here.